Hey everybody! So, can anybody tell me a little bit about what they think encryption might be?
Maybe like some secret like code for spies.
Right, yeah, secret codes or secret messages, but most importantly, messages that are hidden in plain sight. So, looking at all these scrambled up letters, you guys might be a little bit stumped. But, you can see, with just that little keyword right there, where we kind of line up both the bottom row and the top row, and then switch all the columns, we can see the message that is hidden in plain sight. So, like it says, I'm Mitchell Malone,
And I'm Harwant Sethi.
and we're going to be talking to you a little bit about encryption today. So, what is encryption and why is it so important? Well, to answer that question, we're going to start off by saying exactly how encryption works and kind of give some examples throughout history of encryption, why it was needed. Then we're going to talk about, well, what happens if we don't have encryption? Why is it even necessary today? And then finally, we're going to talk about how we use encryption today to keep us safe when we're on the internet and doing other things. So first, how does encryption work?
Let's say I handed you this box of puzzle pieces, and that's it, and you had to try and put together all the pieces to make the picture that it was supposed to represent. It'd be pretty hard. You wouldn't have any idea where to start, what color the edges should be, where the middle might be, anything. You wouldn't have any idea. But if I gave you these puzzle pieces and the box with the completed picture that you were supposed to put together, it would be a lot easier. So with encryption, we get a bunch of scrambled up pieces that have to be reassembled in order to make a message. And we can think of this box as a key. And that key allows you to easier put together those pieces and figure out what those pieces are supposed to say when you put them together.
Exactly. So we're going to go way back in history, so like way back before computers and the internet and things like that, to Julius Caesar in 56 BC. So Julius Caesar was this dude who was the emperor of the Roman Empire. So he had a lot of power, of course, and with power comes a lot of enemies. So he had to find a way to get his messages to all of his followers, his generals, and those kinds of people without his enemies reading what they say. So he came up with this idea for an encryption called the Caesar cipher, or the Caesar wheel. So it's a pretty simple contraption. It's just a little wheel. You can kind of see there's like an outer circle with the alphabet, and then there's also an inner circle with the alphabet. So what this allows us to do is, if we have like a certain scrambled up message, so like doc, for example, we have no idea what doc means. It's complete, gibberish, right? It's not like a ancient Roman word. So that's our scrambled up message. And then we also are going to need some key. Like any encryption is going to need a key, just like the picture of the puzzle. So our key in this case is going to be the word April, which really is actually refers to a number. Can anyone think of maybe a number that's associated with April? Trying to think of like what number month it is.
Oh, 4?
Right, yeah, 4. It's the fourth month of the year. So our code word, or really our code number, the key, is 4. So using that, we can count 4, so do a displacement or a movement of 4. And we have the A, which was originally kind of lined up right around here, then shifted over 4, so it's lined up underneath the E. Now, what we're doing is we're looking for these letters on the inside of the wheel and seeing what letter they match up to on the outside of the wheel. So where do you see D on the inside of the wheel? Right, you see it right by H. So the first unencrypted or decrypted letter in doc is really H. Where do we see A? Well, that's right by E, and H is by L, and K is by O. So hello is what this means. And we're able to figure that out or decrypt it using a key. And it also goes back the other way too. If we wanted to encrypt hello, we just go from the outside in, and we're able to get H goes to D, E goes to A, and so on.
So let's jump forward a few hundred years. Now in 1700, the Pigpen cipher was created. And what this is we have these 4 little groups of letters. And based on the shapes that you receive in the coded message, the encrypted message, you have to go back to your Pigpen cipher here and figure out what letter each shape is supposed to represent. So for example, if we had this sort of half square looking thing, right here, we'd see that that sort of lines up with the H. It has the same symbol as what surrounds the H. The next we have is this box. So we see there's no dots or anything like that, and there's no crosses, but we do see the E is in a box, so that's probably E. Then we have a corner with a dot in it, which is where the L is. And we have 2 of those. And lastly, we have a dot with a outward-facing square, and that's an O. So the Pigpen cipher looks a lot like the Caesar cipher, but just with shapes and dots and crosses instead of letters being offset. The key is here, and the encrypted message is there.
Right? So now we're going to continue to jump forward. So we've seen a few different examples of how encryption is being used across time, but we end up in this period of 1943, which was when World War II was going on. So, of course, there's a lot of need for secret messages in World War II, and the bad guys in this war, the Nazis, used this machine called the Enigma machine to create these messages. And this was said to be uncrackable, to be unbreakable. And what it would do is it would take some text, so the word hello or something, and then we have all these little switches, so every time it'll match up letters to letters, and create some totally strange, so in this case, say like this is kind of the matching and pairing, but it would create a totally random pairing of letters. But because it's going random, it's not just like the Caesar wheel where it's just shifting letters, it's just completely random. There are millions and millions of possible combinations, so it was effectively impossible to just decrypt this by just guessing. This really smart guy named Alan Turing, who really is considered to be the founder of computer science today, was able to crack the machine. So he was a British man, and he was given the task, him and a bunch of other mathematicians, they said, all right, we need to win this war, we need to figure out what these secret codes mean. So he did that by kind of recognizing a certain greeting. So in this case, so again here would be our scrambled up message, just a bunch of gibberish, and then our key. He didn't know the key at the time, but he realized that all of these messages are starting with some sort of greeting. So in this case it would be a time, or really like a hello, the weather today is blah blah blah. And this is the start of each message had the same greeting. So he was kind of able to figure out a few of these pairings right away. And then to get the rest of the pairings, he actually created kind of what's considered one of the first computers out there that was able to go through, still pretty slow compared to today's standards, but much faster than a human could, all the other possible combinations until it found a correct solution. So this allowed him to crack this Enigma machine. So now we kind of went through how some different ciphers work and some examples throughout history. Why do we need encryption today? What's so important? So again, we're going to jump forward in time a little bit to this guy named Robert T. Morris, who was this computer scientist around the 1990s or so, a programmer. And he was wondering, this is about when the internet was just kind of born, and it's really, it's not in everyone's home like it is today, but it was just between some universities and the military and a few other people. And he was kind of wondering, I wonder how big it is. I wonder how many computers are connected to this internet. So he had good intentions because he just kind of was curious, and he created this program that would take advantage of poorly encrypted passwords, actually. So in this case, might be an example of if you have a really basic password or something, like you just start swapping the A for a 4 or the O for a 0, so something pretty easy. He was able to crack this encryption just using a brute force method where he's just trying a bunch of different passwords until he finds one. And once he has that password, he's able to send an email out to all the other computers that this computer was connected to, and then so on and so forth. So then in each of these computers, and his program goes through, cracks the password, and sends an email to all the computers this was attached to. So the problem with this, though, is that he kind of made a bit of a mistake in his program, where instead of just sending it to all the other computers, it actually would keep copying itself on the original computer, keep copying. So this works just how like a virus would work today, or a bacteria if you get a cold or an infection, where it just kind of keeps multiplying in your body until all of a sudden there's so much of it in your body, and you start feeling really sick, and then you slow down and you kind of shut down. And that's kind of what happens to a computer. So this is what's kind of considered the first computer virus or computer war.
So today, these kinds of viruses and attacks are getting more and more complex, and they're happening all across the world, all the time. So this little graphic that we have here shows you that all these little pings, these little dots that you're seeing, these are cyber attacks. These are people trying to break encryption that companies say, maybe in the United States, have and get information away from those companies so that they can sell it or do something else with it that might be valuable. So as you can see, we've got all these dots flying all over the place, and these are happening literally every second. So we need people to help protect us and protect companies and our information from these kinds of attacks.
Right. So one way that we can kind of do this is we use something called a NOC. So as a network operations center, or just kind of a place where you have all these computers, basically a geek stream, like kind of my dream. It's a pretty cool looking room. And in this we have a lot of computer security experts and programmers that monitor the network and look at maps like that and see where these attacks are happening and try to come up with strong encryptions to prevent these attacks, prevent our data from getting stolen. So that's what happens if encryption fails, is that we could really get a lot of things stolen from us online and through cyberspace. So how do we prevent that today? Like, what kind of techniques do we use today? Well, one technique that we call, it's called the Advanced Encryption Standard, or AES. So this was about, I think around 10 years or so ago, a bunch of cryptographers and programmers and computer science and mathematicians came together and were like, we need one super strong standard that we can use that we know won't be able to be broken. So they came up with something called a symmetric key, which just means it's the same key. So you have the same key that you use to encrypt something, you use to decrypt something. So this is a lot of like the Caesar wheel or the Pigpen cipher that we saw before, but it's a little more complex in that instead of just scrambling the letters up, we completely scramble even all the characters up, and it's just total gibberish. And it does that basically using a mathematical function or an equation. So in this case, we might have our message